Hi geographers, and welcome to this, your second lesson in the Natural Hazards unit. Today's lesson is all about plate boundaries. For the purpose of this lesson and for GCSE, you need to know 3 different plate margins. They are destructive, constructive and conservative plate margins. As well as being aware of the names of these, we also have to have an understanding of what is happening at each of these different plate margins. Some of you will be aware that we covered this in Year 9, and so you may already have some base knowledge to work from. Hopefully you've got your booklet already in front of you, and you will notice that in your booklet there are 3 diagrams. The first diagram is a destructive plate margin diagram. I'm going to explain what happens at a destructive plate margin, and it would be really great if you could add some of these key labels that I have put on here for you. So at a destructive plate margin, we've got oceanic crust and continental crust moving towards one another. But because oceanic crust is more dense, it is pushed underneath the continental crust, and we say it is subducted underneath continental crust. Where this happens, where the oceanic crust is subducted underneath the continental crust, we have friction, and as a result of that, earthquakes will occur. Not only this, but as the oceanic crust is being forced underneath the continental crust, it is melted and destroyed by the mantle. And this creates a magma chamber, which eventually, as pressure builds, will be released during an eruption by the volcano. At destructive plate margins, we find that we have a more sticky, viscous magma, and as a result of that, it creates steep-sided composite volcanoes and has more explosive eruptions. The reason the eruptions are more explosive is because the viscous lava fills gaps and cracks in the rock, and pressure builds behind that, and when it finally is released, we see a more explosive eruption. An example of a destructive plate boundary is the Nazca plate being subducted underneath the South American plate. And I should also add that where this occurs, where this subduction occurs, we call it the subduction zone. You might want to pause the video here just to add some of these little labels to your diagram. Your diagram looks like this. Hopefully now that is labelled with oceanic crust, continental crust, subduction zone, earthquakes as a result of friction, volcanic eruption, and make sure you make it clear that the oceanic crust is melting, because oceanic crust can be destroyed, whereas continental crust cannot. Okay, so this is an explanation of what happens at destructive plate margins. To go in the box to the right of your diagram, what you might like to do now is pause the video, see if you can fill in the So I'm going to go through, and then you may want to pause to give yourself time to write this up. So tectonic plates move towards destructive plate boundaries due to convection. We know that heat rises, and as it does that, in the mantle, the mantle is moving, allowing the plates to move. The oceanic plate is pushed underneath the continental plate, more dense, and does not float on top of the mantle like continental crust does. As the oceanic plate is pushed underneath, its jagged surface causes it to lock against the continental plate. Over time, pressure builds until it becomes too much and is released. This is an earthquake. As the oceanic plate gets closer to the core, it will also heat up and melt, creating a magma. This new magma will eventually rise up to the surface through fissures, cracks. So I would recommend that you pause the video here, and next to in the box to the right of your destructive plate margin diagram, write out this explanation. Okay, the next plate margin that we're going to look at is a constructive plate margin. So at a constructive plate margin, we've got two plates that are moving apart from one. An example somewhere in the world that this is happening is the Mid-Atlantic Ridge. And when magma forces its way up through the crust above it, that can cause earthquakes. And eventually, when magma comes out through the crack in the rock, it can form volcanoes. So an example of a volcanic island formed on a constructive plate margin could be Iceland, for example. We find that the lava at constructive margins is hot and more fluid than at destructive plate margins, and as a result of that, we get broad and flat shield volcanoes forming at constructive plate margins. They're a slightly different type of eruption as a result of the difference in lava. You might want to pause the video here to see if you can add the explanation to your to see if you can fill in the gaps. Okay. So tectonic plates move to the at constructive plate boundaries. Again, that's due to convection currents in the mantle. As these plates pull apart, stretched and weak in the middle. As a result of this, it sinks down into the mantle, creating a rift valley. On either side of this rift valley, there will be fissures where magma can escape from the mantle. An example of this is the East African rift, and I have included some diagrams here of the East African rift valley. You might want to pause the video here so that you can write this explanation next to your constructive plate margin diagram. The last plate margin that we need to look at today is the conservative plate margin. And an example for this one that we've got is the San Andreas Fault in California. So at conservative plate margin, we've got two plates that are moving past each other. And the rock will be very jagged and they might snag and lock on one another. And this creates friction and pressure will build. It's when that pressure is released and that there's a sudden jolt that we see earthquakes occur. We don't have any volcanoes on these plate margins because there's no magma. You might want to pause the video here so that you can see if you could place the words in the correct gaps. So at conservative plate boundaries, plates can either move alongside each other or in the same direction but at different speeds. And they can therefore lock as they move next to each other. However, convection currents will continue to push them and build. When this pressure becomes too much, the plates will jolt apart, creating a series of shock waves. This is known as an earthquake. No volcanoes form at this plate boundary as no plates are destroyed. You might want to pause the video here to give yourself time to write this. So we've covered each of the 3 plate boundaries that we need to for today. If you want to do any further reading or learning, your teacher might direct you to the Oak Academy videos as well. Thank you for listening, Year 11.